All right, so we'll continue on with the back of your notes, and we're taking a look at the net change theorem. And this really is nothing more than the fundamental theorem of calculus, but it's for an application, and I think you'll start to see a lot of uses for the second fundamental theorem and eventually for the first fundamental theorem and eventually the second one. So one thing I want you to see right at the top is for these, you may use your calculator to integrate. And this is a great use of your calculators. There's no need to go through the whole process of the integration. So I've highlighted a few things for you. The definite integral of the rate of change. This is what we're using. So we're integrating the rate, integrate the rate. This will give you the total change in that quantity on an interval. So you'll see that I have an example about oil leaking. And my question is about how much oil, and my given information is the rate at which the oil is leaking. So there I'm wanting to calculate the total change or that net change in the amount of oil. And the information that I'm given is the rate at which it's leaking. So I'm going to integrate the rate to do this calculation. And hopefully that should make sense to you that when you integrate velocity, it goes back to position. So when you integrate a rate of change, it would go back to an accumulation of an amount. So again, it's nothing more than the fundamental theorem of calculus. So let's take a look at this first problem. It says at 1 o'clock p.m., oil begins leaking from a tank at a rate of. So here's your f of x, and it is a rate. And this is in gallons per hour. So it asks how much oil. So there's your question, how much. So anytime you're asked about how much and you're given a rate, you're going to integrate the rate. Now, your limits of integration, you just want to be careful how you interpret those. This is from 1 o'clock p.m. to 4 o'clock p.m., but that does not mean that you want to integrate from 1 to 4. You want to integrate from time 0 to however much time has passed. So that's the first thing I want to talk about on this. 1 o'clock is our time 0. That's the beginning of the accumulation. And 4 o'clock is then telling us that 3 hours have passed. So we'll go from 0 to 3. I'm going to call this N for net change. I'll write this as the integral from 0 to 3. And then my rate, which is 4 plus 0.75 t. Remember to put a dt with that. And then you can use your calculator to do this integration. I do not need to see any other work other than your equation and then your answer. So use your calculator to do this. And I'm just having a lot of trouble writing words, so I'm just going to say it again. Use your calculator. I tried to circle that for you, and I'm struggling with that even. And so your net change, having used your calculator, is 15.375, and that would be gallons. So 15.375 gallons. And then your second question, it asks how much oil is lost from 4 o'clock to 7 o'clock. Now, The 4 o'clock in this is not the time 0, but rather your time 3. So once we've established a time 0 for a problem, that does not change. So 4 o'clock is your time 3, and then we have 7 o'clock, and so the hours that would have passed by would be 3 more hours, so your t is a 6. And so now we're going to integrate the rate again, only this time going from time 3 to time 6, and 4 plus 0.75 t dt. Again, use your calculator, and n will equal, and this one, 22.125 gallons. Make sure that you do check this out on the calculator, and again, this is all the work that I need to see. So notice that 3 hours had elapsed from time 0 to time 3, and we had 15.375 gallons of oil lost. And then in part B, we still had 3 hours elapsing, but more oil was lost, was 22.125 gallons. So in part C, what do you notice as you compare the answers? Well, I hope that you are noticing that more oil is lost. So I was going to try to type that for you, but I don't think I can get that in there. So more oil is lost, and you'll find that this is because the rate that the oil is leaking is increasing. It's got a positive slope. It is increasing, and so you could think of lots of reasons why that might be happening. One might be that the hole in whatever this tank is getting bigger, or a variety of reasons. It could be positioned so that it just comes out more quickly in that second part of the time. So more oil is leaking out, and that is because the rate that oil is leaking is increasing. I do have that written out on my answer key of the notes, or you can listen to the video again to get that. All right, so I'm going to move us on to the next idea. These are all applications. So this is about displacement, and on displacement, if you're calculating the net change in position of a particle, so a change in position, then you're doing the fundamental theorem of calculus, but we call this displacement. And so again, you are integrating the rate. This rate happens to be the velocity. So once again, integrate the rate. And the rate in this case is v of t. So we'll compare displacement to total distance traveled. Now, total distance traveled means that we're not just looking at the position, the final position of this particle, but we're actually going to take into account when it was moving in a negative direction to the left. And so to account for those times, we will integrate the absolute value of the rate. So if you're trying to calculate more than just the change in position, but rather the total distance traveled, then you integrate not just the rate, but the absolute value of the rate. So the absolute value of v of t. Now, once again, I'm going to let you use your calculators, and this will be really nice if you remember integrating absolute value takes a lot more time if you do this by hand. When you use your calculator, you just type it in and it does all the magic work for you. So we'll look at your last examples. On your papers there, we have for part A, I've given you the velocity is v of t equals t to the second minus t minus 12. And I've given you the interval. Part A, I'm asking you to find the displacement of the particle. So notice that word displacement. So displacement will equal the integral from 1 to 5. Now this time, your time, t, is given with its upper and lower limits, not as a time of day. So we can use the 1 to 5. And then our velocity, which is t squared minus t minus 12 dt. So you just will use your calculator and you will find that the the displacement is negative 56 thirds, or negative 18.6 repeating. And then you can look to see what it was measured in. Since the rate was in feet per second, this will be feet. So negative 18.6 feet. And then for part B, using that same information, it wants the total distance traveled that the particle traveled over the interval. So I'm going to use a t for total distance. Again, I'm going to integrate from 1 to 5, but this time instead of integrating just the velocity, I'm going to integrate the absolute value of the velocity. So make sure when you're using your calculators for this, after you type in your integral sign, that you select absolute value of the function. So we would do the absolute value of t to the second minus t minus 12 dt. You don't have to do any work. The calculator will do it all for you. And so that total will be 79 thirds, which equals 26.3 repeating feet. And again, this is the total, taking into account the negatives and adding that in as a positive. So there you've got your notes. As you do your assignment, I will make sure you know which ones you're allowed to use your calculator on. I'm mostly interested in your setup on these. So good luck, and let me know if you have any questions.